All right, calculus, we are going to continue on with the idea of exponential growth. Just slightly more complex methods in working through these problems, but still the same idea. So earlier we looked at the idea of dy dt is y equals c e to the kt. Okay, so if it said the rate of change, that's the dy dt, of some quantity y is directly proportional to y, that's directly proportional means multiplied by k, that's what we would have. But let's say the rate of change of y, so dy dt, is directly proportional to 4y, or is proportional to 4y. So that would tell me that the rate of change is k times 4y. That's what we're looking at. So this really doesn't change a whole lot except there's a constant 4 in here. So how would that affect it? Okay, well, let's work our way through it. So we'd multiply by dt on both sides to get rid of that dt. And then we have this y needs to move down there. So we'd have dy over y equals 4 times k dt. We integrate both sides. And when you integrate both sides, then you get natural log of absolute value of y equals 4 kt plus c, of course. Now, if you're kind of thinking ahead, what you would do from here, well, we got the e, and we got y is going to be equal to e to the 4 kt plus, times e to the c, which equals c e to the 4 kt. All right, that's not that big a deal. Well, we can do that. What if it said the rate of change of y is proportional to 4 minus y? And so is proportional means multiply by constant. And in this case, we're using the letter k. So we would have the rate of change, dy dt, is equal to k times, now this time we're going to have 4 minus y. 4 minus y. Okay, so really, again, not too big a deal, but let's see how we would work around it. So let's get rid of the dt on the left side, move it over to the right side, and let's also divide by this 4 minus y because we got to move that over with the y over here. So we'd have dy over 4 minus y equals k dt. And you might be asking yourself, did I have to move the whole 4 minus y? Kind of. I mean, you really did, because we can't just move the y, because this 4 minus y is like one term. It's grouped there. So the whole thing has got to come over. Now, if I were to take the antiderivative of this on both sides, on the left side, let's give myself some workspace here, split it up a little bit. So on the left side here, we would have, this piece down here is 4 minus y, so we're looking for a natural log. Now, because we would need the derivative on top, that means we actually need a negative in there. So that's like saying u equals 4 minus y du is going to be negative 1 times dy, but there's no negative 1 in there, so I got to multiply the negative by the du, make this positive. So I really need a negative. Taking the antiderivative of negative du over u, and then that gives me negative natural log of u, which in this case is 4 minus y. And on the other side, well, that's much easier. That side's just going to be equal to kt plus c. And then, we keep working this through, kt plus c. Well, this negative here, I can multiply that to the other side, so negative kt plus c, which is really like negative kt minus c, which is still negative kt plus c. And then we take the e of each side, okay, no big deal, and then we got 4 minus y equals e to the negative kt times e to the c. So it's really 4 minus y equals, we're almost there, c e to the negative kt, and then we finish it off. We move y over to the right, we move c e to the negative kt to the left, and then we're going to have in the end here, 4 minus CE to the negative KT equals Y. Boom! Shakalaka. There we go. Done did it. Let's do another one. What if it said the rate of change, so that's like dy dt of y, is inversely, inversely proportional to y? What does that mean? Okay, here's what that means. That means that proportional, so let's break this down. Proportional, that means it's k times y. But if it's inversely proportional, that means that we're really looking like inversely proportional. That would be k divided by y. So this is really saying dy dt equals k divided by y. Ooh. That one's actually pretty easy to differentiate. So you multiply by y, multiply by y, multiply by dt, multiply by dt, and then you got the dt's simplifying, the y's simplifying, you got y dy equals k dt. Take the antiderivative of both sides and you would have y squared over 2 equals kt plus c. Boom. That was it. So that's actually very easy to kind of set up as an anti-differentiate. But this word inversely proportional, that is key, meaning that's a constant divided by that. So that's what we have so far. Let's take a look at this last one here. And we'll kind of pause the video for a second. We have the rate of change of y is proportional. Proportional to, that means k times something. It's actually meaning that it's k times, what do we got? K times square root of y. Okay, so how would that look? That the rate of change is, let's pick a color here. How about maroon? Dy dt, there we go, of y is proportional to, so that means multiply by k. So we're going to have this k times this right here, y square rooted. Well, how would you deal with that one? All right, so we got to move stuff around again. So we're going to have dy over square root of y equals k times dt. All right, it's not really as bad as you would think, because if I take this y and move it up, then I'd have y to the negative 1/2 dy. That's a little bit easier to deal with, equals k times dt. Now I take the antiderivative of both sides. Then on the left side, I'm going to have y to the, well, negative 1/2 is a power, so I just add 1 to it. Negative 1/2 plus 1 is 1/2. I divide by that same number, 1/2. And then that's equal to kt plus c. Not a big deal. So let's say I were to multiply both sides by 1/2, multiply both sides by 1/2 to get rid of this half here. Then I'd have y to the 1/2, or in other words, square root of y, equals kt plus c, all divided by 2. Then how do I get rid of that square root? Well, I square both sides. So I have kt plus c divided by 2, squared, check, done, awesome. Excellent. That was so easy. So a lot of it's about interpreting the prompt and just kind of doing the steps from there. So interpreting this prompt, the rate of change y dy dt is proportional to times k, square root of y, square root of y. No big deal there. Now let's apply it. Suppose you fill a tin can with water and then punch a hole near the bottom. The water leaks out quickly at first, but then more slowly, because right now, when it's got a lot in it, so more water equals more pressure, because that's what's happening. There's more water on top pushing down on it, but when there's less water, then it's less. So what else are they saying here? In physics, it can be proved that the rate at which the water's height h changes, because stuff leaks out, is directly proportional to the square root of its height. Okay, so that's saying dh dt, that's the rate of the height, is proportional, so that means k times, the square root of its height, square root of h. Boom! That's what it means. Suppose that at time t equals 0, so t equals 0, the height is 12 centimeters, h equals 12 centimeters. And dh dt at time equals 0, so time equals 0 is for both of these. dh dt is negative 3. Find the value of k which satisfies this relationship. That's actually way easier than you would think. Because look at what we have up here. We got dh dt, which is negative 3. So if I start with dh dt equals k times square root of h, dh dt, this first piece, that's negative 3, it says. And it's important here that these are in common units. That's kind of a big deal. So negative 3, and then k, we don't know, so I'm going to leave the k in there. And then the h here is, well, that's 12, it says. So that's going to be square root of 12. So what does k equal? K is going to be equal to negative 3 over square root of 12. Technically, that's plenty fine. We can just leave it there. Nothing else required. That was it. That's all you needed. Let's try another one here. Solve the differential equation to find h as a function of t. Ooh. Alright, so we know that k equals negative 3 over square root of 12. We know that much. And we know that dh dt is going to be k times square root of h. Hey, good thing we solved one like this earlier, right? Where it said dy dt equals k times square root of y. Let's see what we finished up with. We said y equals this stuff. So that's like saying h equals kt plus c over 2 squared. Excellent. Let's work that out. So we already solved that from earlier. We know that we have, if we were to work this out, that h of t, or h, would equal, we said k times t plus c, all divided by 2, then squared. All right, considering this, let's see what we can do. Well, we know what k is. We got to figure out what this c is, that first constant as well. Actually, no, yeah, we still need to figure that out. So k is negative 3 over square root of 12. So this is negative 3 over square root of 12 times t plus some constant, all divided by 2, and then squared, equals height. So what is c? Well, I know that when t equals 0, h equals, what was it, 12? There we go. So let's work with that. That's going to tell me, using this information, let's plug this stuff in, that 12 equals negative 3 over square root of 12 times 0 plus c divided by 2 squared. Okay, so let's take that a little bit further. So this term here is 0. That goes away. So we got 12 equals c over 2 squared. Okay, well, we can get 12 equals c squared over 4. Multiply both sides by 4. And then we got 48 equals c squared. So c equals square root of 48. How does that help us? Well, now we have C. So we've got K and C. So what is the final answer? The final answer here, h of t, you could say h is equal to negative 3 over square root of 12 times t plus square root of 48 divided by 2. All of that squared. All right. Excellent. Now it's about to ask me something interesting. It says solve algebraically for a time when the can becomes empty. So it sounds complicated, but it's really not, because when the can becomes empty, what's that really telling us? That's really saying that the height is equal to 0. So I'm going to set this equal to 0 and then just solve. No big deal. So set the height equal to 0. That gives me 0 equals negative 3 over square root of 12 times t plus square root of 48. All that divided by 2 and then squared. Alright, let's square root both sides, and then I still get 0 equals negative 3 over square root of 12 times t plus square root of 48, all divided by 2. Let's multiply both sides by 2, and then I still get 0. 0 equals negative 3 over square root of 12 times t plus square root of 48. I'm going to move this first term over. That'll give me 3 over square root of 12 times t equals square root of 48. So now I got to get rid of this fraction here. So I'm going to multiply by square root of 12 and divide by 3. So multiply by square root of 12 and divide by 3. And that'll give me t. So t equals square root of 48 times square root of 12 divided by 3. And technically that's done. If I were to do like a multiple choice question, I could figure this out, but let's go ahead and simplify. So 48 times 12, what would that be? Well, that's kind of 12 times 12 times 4. So that's 12 times 12. So we would have, that's the same thing as saying, because this is really 4 times 12. And then we have another 12 in here. So we're going to have square root of 4 times square root of 144 divided by 3. Well, check this out. Square root of 144, that's 12. Square root of 4, that's 2. 2 times 12 divided by 3, that's 24 divided by 3, which equals 8. T equals 8. Check. Done. Number 46 is in the books. Alright, so watch this video again. It's a quick one. It's a short one. Really just one main example, but it's got a lot of kind of problem solving going through it. Alright, so that's all we got for this one. Happy stars. Moving on. See you later.